Electron Configuration by Joshua Yam, Luke Melas-Kyriazi, and Simon Ma. We all know that atoms are made of two parts, the dense positive nucleus and the electron cloud around it. But what exactly is this electron cloud, and how is it organized? As you probably remember, electrons orbit around the nucleus in orbitals, spaces where electrons are likely to be found, and orbitals are arranged based on energy level. There are 7 of these energy levels, as shown in the periodic table, starting from hydrogen and helium on the top of the table and moving downward. Inside an energy level, electrons are classified by their sublevel, or shape. The shapes in increasing order are S, P, D, and F. The S shape has 1 orbital, P has 3, D has 5, and F has 7. Take chromium, for example, element 24. We can name it by following a few simple rules about electron configuration. The first rule, the Aufbau principle, states that electrons can enter into states according to their energy level. In other words, electrons can fill the 2s sublevel before the 2p and 3s sublevels. However, after 4s, things got a little bit more difficult. 3d is filled between 4s and 4p because of its specific energy level, and as a result, the d and f sublevels do not match up with the principal quantum number. Other than this trick, the electrons fill in a standard configuration from lowest to highest energy level, which is often depicted by a chart with diagonal arrows. The second rule is Hund's rule, which states that all orbitals of a sublevel must contain 1 electron before any orbital is filled with 2 electrons. This is especially important in the Aufbau diagrams, such as the one for chromium. As you can see, the 3d sublevel has 4 partially filled orbitals, not 2 completely filled orbitals. The third rule is the Pauli exclusion principle, which states that no 2 electrons in an atom can have the same 4 quantum numbers. This is a fancy way of saying that all electrons are unique. The key point of this principle is that the 2 electrons in the same orbital can be identified by their spin. One has spin up and one has spin down. Finally, let's find the complete electron configuration of titanium. By looking at the periodic table and using our 3 rules, we can see that the final result is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 2. This can also be abbreviated by replacing the beginning with its closest noble gas, argon, to get the configuration argon 4s, 3d, 2. And that's electron configuration. Thanks for watching.